Welcome to the AI Research Roundup. I'm Alex. Today we're looking at a paper from the Hugging Face trending list, published on September 12, 2025, which was about 5 days ago. The standout claim is that self-supervised contrastive goal reaching makes independent multi-agent teams cooperate and explore under extremely sparse feedback, often achieving non-zero success, where standard methods never register a single win. The paper is titled, Self-Supervised Goal Reaching Results in Multi-Agent Cooperation and Exploration. And the implications for training coordinated agents without handcrafted rewards are quite significant. In short, agents share one actor and critic, learn from a single goal observation, and consistently beat strong baselines across SMAC battles, particle chases, and multi-legged control. On X, one post claims the method solves impossible teamwork by replacing complex rewards with a single goal, reporting 95% wins versus 0 for old approaches. The thread credits independent contrastive reinforcement learning and explains that self-taught cooperation emerges. Engagement looks solid, with about 188 likes and multiple replies, which signals strong interest in the results. So the previous segment highlighted strong results under sparse feedback. Figure 1 illustrates the core setup. A quadruped ant is controlled by 4 agents, each policy handles one leg with 2 joints, and the team must move the body to the red cross goal. The agents act independently yet share parameters, which means each uses local observations but benefits from a common learner. Success depends on coordinated timing, because any single leg cannot steer the body alone. No shaped rewards or distance metrics are provided, so reaching the marked position drives learning. So the previous figure introduced the quadruped control setup. Figure 2 shows the 3 evaluation families that ground the study: a simple particle world for tagging, real-time squad battles, and a multi-legged ant moving to a goal. The left panel depicts MPE tag, which stresses partial observability and coordination to corner a faster prey. The middle panel presents SMAC-style skirmishes, so teamwork and unit roles matter. The right panel illustrates the multi-agent ant, where separate limbs must synchronize to reach the blue dome goal. Alright, the previous figure outlined the environments. Figure 3 reports learning curves for MPE tag under 3-agent and 6-agent teams, which makes the comparison concrete because mean episode returns rise as training progresses. The blue ICRL curves climb faster and peak higher, while the red IPPO trails. The gap is modest with 3 agents but becomes large with 6, showing stronger scalability and quicker convergence. Alright, the previous figure emphasized gains on particle tag. Figure 5 presents win rates across 5 StarCraft squad battles, and the blue ICRL curves rise quickly to high success, while the red IPPO line stays at 0. The orange MAPPO line only climbs on 3M, and it levels far below blue, which shows ICRL learns reliable teamwork from sparse goals. The 2S3Z, 6H versus 8Z, 8M, and 3S versus 5Z panels all show non-zero wins only for ICRL, so exploration clearly becomes directed here. So the previous figure showed win rate trajectories. Table 1 compiles the peak numbers, which makes the contrast unmistakable across tasks. ICRL tops MPE tag with much higher returns for 3 and 6 agents, reaches about 270 success rate points on ANT versus single digits for IPPO, and posts near 100% wins on several StarCraft battles. Baselines remain at 0 in most SMAX maps, even when MAPPO and MASCR are included. Wrapping up, 2 takeaways stand out. Self-supervised contrastive goal reaching turns a single goal snapshot into coordinated multi-agent behavior, and the shared actor critic with contrastive critic scales to harder teams where sparse reward baselines stall. The broader implication is simpler task design with emergent exploration. That is it for the AI Research Roundup. I am Alex. Thanks for listening.